Okay, let's dive into this. Welcome to our explainer. Today, we're exploring a story that genuinely reads like a high-stakes Hollywood thriller, except it's entirely real. We're looking at the intensely dramatic life of a 20th century mathematician whose profound genius fundamentally changed the course of human history. We are talking about Alan Turing. He's widely celebrated today as the father of modern computer science and artificial intelligence. I mean, think about it. Whether you're watching this on a laptop, listening on a smartphone, or chatting with an AI, the very foundation of the technology you're using at this exact second traces its roots right back to his extraordinary mind. How did one mathematician shorten World War II and invent the future of artificial intelligence? That right there sets the stakes for everything we're about to discuss. It's just a massive juxtaposition. On one hand, you have the quiet, deeply abstract world of theoretical mathematics. And on the other hand, you have the violent, global stakes of a world war. Turing bridged that impossible gap. The ideas he developed didn't just stay on chalkboards, They broke unbreakable enemy codes, and then they went on to literally birth the entire digital age. Section 1. The start of an extraordinary genius. Let's move to the timeline and see how this builds. From a very early age, Turing possessed a mind that approached complex logical problems unlike anyone else. Born in London in 1912, he was a kid just deeply, deeply fascinated with math and logic. By 1936, he'd conceptualized the Turing machine. Between 1939 and 1945, he dedicated his life to secretive wartime efforts at Bletchley Park. And then, shockingly, an untimely death in 1954. It's this sweeping, incredible arc of massive highs and absolutely devastating lows. It was really during his time studying math at Cambridge University that his early brilliance began to take shape. Turing had an absolute fascination with computation, meaning the actual process of calculating. But more importantly, he was obsessed with the theoretical capabilities of machines. He had this unique, almost visionary capability to view complex computational problems from entirely new perspectives. He was seeing wide-open possibilities where others just saw mathematical dead ends. Section 2. Turing Machine. Foundation of computers. We're transitioning here from pure mathematics into the spark of an outright technological revolution. Now, what's really interesting about this is the word theoretical. In 1936, he proposed the Turing machine. But actually, scratch that. It wasn't a physical machine made of cogs or wires or metal at all. It was a purely imaginary mathematical model. Yet this totally abstract concept laid the absolute foundation for modern computer science. Literally every piece of modern software you use today operates on the fundamental principles Turing outlined in that 1936 paper. So, how did it actually work? Well, the core logic of the Turing machine is broken down into 3 steps. First, you input a computational problem. Second, you process it using a rigid set of step-by-step instructions. And third, you arrive at the solution. I know, it sounds super simple to us now because, well, that's exactly how we write computer code today. But back then, the realization that any solvable mathematical problem could be broken down into step-by-step programmable machine instructions, that was the blueprint for the entire future of computing. Section 3. Hero of the Second World War. But Turing's theoretical work was soon interrupted by a horrific global reality. We're shifting to the climax of his story now. When the Second World War broke out, his intellect was suddenly called upon to quite literally save the world from tyranny. During the war, Turing was stationed at a highly secretive facility in the UK called Bletchley Park. His mission? Cracking the codes of Germany's infamous Enigma machine. See, the Enigma machine was used by the enemy to encrypt their most vital military communications, and everyone considered it functionally unbreakable. But Turing and his team applied immense mathematical rigor to build physical machines that could decrypt these messages. It was just an astonishing triumph of intellect, logic, and computing over brutal force. Historians widely agree that his work helped shorten the duration of the war and saved millions of lives. So, the crucial point here is the sheer, unimaginable scale of his wartime heroism. The intelligence gathered from the codes Turing helped break provided the Allies with a massive, decisive advantage. Without firing a single bullet himself, this mathematician fundamentally altered the trajectory of the bloodiest conflict in human history. Section 4. Can machines think? This era officially marked the birth of artificial intelligence. After the war, with the world saved, Turing pivoted straight back to inventing the future. He continued to push the boundaries of computer development. But he didn't just want machines to calculate numbers anymore. No, he dared to ask a profound, almost philosophical question. Can machines possess human-like thought? To answer that question, he proposed what we now know as the Turing Test, a method of inquiry to determine if a machine can exhibit intelligent behavior that's indistinguishable from a human. And this wasn't just some fun sci-fi thought experiment, it became a critical cornerstone that still completely guides modern AI research to this very day. And this brilliantly illustrates his core theory. It was simple but incredibly revolutionary, comparing human conversation versus machine conversation. Turing argued that if an evaluator is having a text-based conversation with both a human and machine, and the evaluator simply cannot tell the difference between the two, well, then the machine must be considered intelligent. It completely shifted the goalposts of what technology could even aspire to achieve. Section 5. An immortal and inspiring legacy. 41. That is the devastatingly young age at which Alan Turing died in 1954. We really have to balance the deep tragedy of his end with the monumental triumph of what he left behind. Following the war, despite his immense world-saving contributions, Turing was subjected to a very harsh social and legal environment prevalent in that era regarding his personal life. It brought him immense difficulties and ultimately preceded his tragic passing. A brilliant, brilliant mind was lost far, far too soon. But the story doesn't end in defeat. Over the subsequent decades, history rightfully corrected its view, and his brilliant contributions were ultimately vindicated and universally honored by future generations. Today, the absolute highest distinction in computer science is the Turing Award. It's widely recognized as the Nobel Prize of computer science. Future generations realize that the entire digital world we live in was built on the foundation he poured. So, let's distill what we can actually learn from his life. Curiosity and imagination birthed new tech. He dreamed up a theoretical machine that became our everyday reality. Tough problems need new perspectives. Math and logic are incredibly strong foundations for solving real-world crises. Big ideas are often way ahead of their time, and continuous learning and experimentation are the keys to long-lasting success. His scientific curiosity left an impact that will absolutely last for generations to come. I want to end our explainer today by leaving you with this final provocative thought. How much more will AI technologies born from Turing's ideas change our future? The next time you unlock your smartphone or ask an AI chatbot a question, remember the brilliant, complex, and genuinely heroic mathematician who made it all possible. Thank you so much for joining me to explore the source of our modern digital intelligence. And as always, keep questioning what comes next.